Good morning everyone. Myself Vikas Singh, Assistant Professor in the Department of IT at Malot Institute of Management and Information Technology, Malot. Today, I will deliver a lecture in the subject of software engineering and at the topic of software lifecycle models. In this lecture, we will discuss about the various software development lifecycle models. Those are classical waterfall model, iterative waterfall model, prototype model, evolutionary model and spiral model. For this lecture, I will use as a reference three books. The first one is the Fundamental of Software Engineering, that is authored by Rajiv Mal. Second one is the Software Engineering written by Somerville, and third one is the Software Engineering, a practical practitioner approach by Pressman. I have used these three books as a reference for this lecture. Before going into the software development lifecycle models, we have to know about what is the software engineering. Software engineering is an engineering discipline that is concerned with all the aspects of software production. Software engineers should adopt a systematic and organized approach to their work and use appropriate tools and techniques depending on the problem to be solved, the development constraints and the resources available in that environment. The question arises here, what do you mean by the program and what is the software? When we are solving a problem without following up the particular methodology or without following up the particular development steps, that is known as the non-structured approach, that is of the solving a problem is known as the program. When we are writing a program, solving a problem by means of using unstructured method, and when we are solving a problem by following up a particular structured manner, by following up the different steps, different life cycle models, by following up the different phases in the software development life cycle models, then that is known as the software. Software is the structural approach to solve the problem, and software engineering is the discipline that is concerned with all the aspects of that software production. Now, here we will start the different life cycle models of the software development life cycle. When we are concerning about the software development life cycle, the different models are classical waterfall model, iterative model, evolutionary model, spiral model and the prototyping model. We will start from the classical waterfall model. Classical waterfall is the basic model and the first one model that divides the life cycle into different phases. Those phases are the feasibility study, requirement analysis and specification, design, coding and unit testing, integration and system testing, and at last there is a maintenance phase. These 6 steps are known as the different phases of the software development life cycle. In short, it is also known as the SDLC. That diagram shows the how one step follow the another step. In the classical waterfall model, at the first one step we will do the feasibility study of the software. After the feasibility study is performed, then we go for the requirement analysis, design, coding, testing and maintenance. Each further step is followed by the previous one step. Regardingly, we can say in the classical waterfall model, requirement analysis step requirement analysis step is followed by feasibility study, because these all models follow a sequence. For that reason, this one model is known as the classical waterfall model. Phases between the feasibility study and testing are known as development phases. Among all life cycle phases, maintenance phase consumes the maximum effort. Among development phases, testing phase consumes the maximum effort. That is also shown in the diagram. Here we will check that in the requirement specification phase we have required with only the very small amount of efforts are required, but at the time of maintenance the maximum efforts are to be consumed at a time. In the classical waterfall model, most organizations usually define standards on the outputs produced at the end of every phase, and at the entry and exit criteria for every phase. They also prescribe specific methodologies for specifications, design, testing, project management and others. In the classical waterfall model, the guidelines and methodology of an organization are called the organization software development methodology. In the software development organization, each software development organization expects fresh engineers to master the organization's software development methodology before starting up the new project. This organization required with each fresh engineer, each of his engineer is to be concerned about the software development methodology followed by the organization. And here the software development methodology of the organization is the guidelines and methodology that is followed by an organization for development of the particular software. The first one phase in the software development life cycle model is the feasibility study. The main aim of the feasibility study is to determine whether the developing of the product is financially worthwhile and technically feasible to develop the project. In the when we concerning about the roughly understand what the consumer wants, the different data which would be input to the system is followed up in the feasibility study phase of the software development life cycle model. When we are following up the feasibility study, there we have to find out the different resources required by the system, cost of the development and the development time. These three phases are known as the different three kind of studies of the feasibility study. The first one is the time feasibility, second is the cost feasibility and third one is the material feasibility. These all kind of methodology, these all kind of feasibility studies are required for formulate the different solution strategies for the development of the project, for the development of the overall system. For performing the cost benefit analysis during the feasibility study of the software, we have to determine which solution is the best one solution for the development of the particular project. For that one project, we have to first determine none of the solution is feasible due to the high cost of the development of project, due to the limited availability of the resources. That resources can be in terms of the software, that can be in terms of the backend software, that can be in terms of the printers, in terms of the peoples and anything. And next one is the third kind of feasibility is the technical reasons, technical feasibility. Technical feasibility defines that software is particularly feasible to develop or not by the that particular organization. That is technically there are some softwares that are not technically feasible to design or analyze. That particular software is not as the not to be technically feasible by that particular organization. The second one phase of the software development life cycle is the requirement analysis and specification. The main aim of the this one phase is to understand the exact requirements of the customer, and after the exact requirement of the customer is understand that is required to be also required to be document them. After that document is known as the SRS, that is software requirement specification, and this document serve as the contract between the customer and the organization. And in case of any contradiction after the development of the project. The SRS document, the software requirement specification document, serve as the legal document for solving the misunderstanding between the customer and the organization. For that reason, the SRS document is too much important in the software development life cycle, because all the development is reside on the SRS document. This SRS document specify what are the requirements of the customer, and what is required by the customer to be developed in the software. This requirement analysis, this is done by in the requirement analysis and specification phase of the SDLC. This requirement specification analysis and specification consists of two different activities. The first one is the requirement gathering and analysis, that refers to the collection of the requirements, that can be done by means of interviewing the customer, by means of reading the available documents, and the second one activity in the requirement analysis and specification phase is the requirement specification, that is the documentation of the requirements, that is also known as the development of SRS. Goals of requirement analysis. The requirement analysis phase is to collect all the related data from the customer, and then to analyze the collected data to clearly understand what the customer wants, that is the what is the exact requirement of the customer. After the different requirements of the customer is collected, the next thing that is to be followed in the requirement analysis is to find out that any inconsistency or incompleteness in the requirement, that is all the requirement specified in the SRS requirement to be complete in itself and to be consistent, in the sense that there are not to be the two different requirement to be specified in the document that are contradict with each other. If there are such contradiction are available in the requirement specified by the customer, then the main aim of this analysis phase is to resolve all the inconsistency and incompleteness occur in this particular phase. The next one phase is the requirement gathering. Requirement gathering is to gather the relevant data that is usually collected from the end user through interviews and by discussion with the customers at the particular site. For example, if we want to develop a business accounting software, for that reason when we are working on the requirement gathering phase for collection of the particular requirements of the user or customer, for that purpose we have to interview all the accountants of the organization to find out the different requirements, because the accountant is the organization can specify easily how they are working previously. The requirement gathering phases basically deals with collection of the data of the requirements put by the customer. When we are talking about any software, we have to visit the firstly particular site and interview the different users or different customer that are previously using that particular previous system followed for the purpose of collecting the relevant data regarding the software. After the collection of the data, we have to analyze the data for any incompleteness or inconsistency between the requirements. For the requirement analysis, data usually initially collected from the user, and that involves number of contradictions regarding the incompleteness and inconsistency of the requirements. For that, in the requirement analysis phase usually contain in the requirement gathering phase usually contain several contradiction and ambiguities in the different requirements. Each user typically has only a partial and incomplete view of the system at that particular phase. In the ambiguity and in contradictions are required to be firstly identified and resolved by discussing that particular ambiguities with the customer from where the data is collected. Next, the requirements are to be organized into the particular document that is known as the requirement specification, and that particular document is known as the software requirement specification document, or in short that document is also known as the SRS document. That document, SRS document, specify all the requirements of the customer for this particular software, and these all requirements are are complete and consistent, and after resolving the ambiguity and contradiction between the different requirements specified by the customer. In the requirement analysis, engineers doing requirement analysis and specifications, that engineer is known as the analyst. The engineer, the particular person that is performing, that is collecting the data by visiting the sites, the engineer that is dealing with analysis of the data for removing of different contradiction, different ambiguities, different incompleteness, different inconsistency in the requirements, and then that engineer is specifying and document the requirements. After all the ambiguities are resolved, that particular engineer is known as the analyst in the software development phase. The next one phase in the software development life cycle is the design phase. The main aim of the design phase is to transform the requirement specified in the SRS document into a form that is suitable for implementation in some programming language. In this particular step, regardingly in the SRS document, we are specifying what is the problem, and in the design phase, in the simple words, we are specifying how to solve the problem. Here we are not writing down the code in the particular programming language in the design phase, but we are specifying the different by using the different design methodology like flowcharts, algorithm, DFDs, by using the different UML diagrams to specify how the problem is to be solved. In the technical terms, during the design phase, software architecture is derived from the SRS document. Regardingly, in the SRS document, different requirements are specified, and in the design phase, we are specifying how to solve the problem, how to design, how the particular problem to be solved, that is specified in the design phase, and this is also known as the software architecture phase. There are basically two approaches in the design phase. The first one is the traditional approach, that is also known as the functional oriented approach. Traditional approach is also known as function oriented approach, that in past used in most of the software development, and in the today's arena we are using the second one, design approach, that is the object oriented approach. There are basically two design approaches. The first one is traditional approach or functional oriented approach, and second one is the object oriented phase. We are starting with the first one approach, that is the traditional design approach. In the traditional design approach, that consists of basically two different activities. The first one is the structural analysis, and second one is activity is the structural design. Here we will discuss about the first one. The first one activity, that is the structural analysis activity. In the structural analysis activity, we firstly identify all the functions to be performed by the system. For that, because here we are identifying there are different functions to be performed by the system, different activities to be performed by the system. For that particular reason, this particular model is also known as the, that particular design phase is also known as the, that particular design approach is also known as functional oriented approach. In this analysis activities, we also identify the data flow among the different functions. We also decompose each function recursively into the different sub functions and identify the data flow among those sub functions also. In the structure analysis, there are different methodologies for the carrying out the structural analysis activity. The one of those activity is known as the data flow diagram, or in short that diagrams are also known as the DFDs. In the flow charts, we are specifying how the control is followed, but in the case of data flow diagrams, we are specifying the how the data is flowing between the different functions of the system. After the structure analysis is carried out, we have to carry out the structural design. As we already discussed, if the first one activity to be performed in the design phase is the structure analysis, and after that we have to follow up the second activities, that is the structural design in the traditional approach or functional oriented approach of the software development life cycle. The structural design is carried out by means of two different methods. The first one is the architectural design and second one is the detailed design. Architectural design is also known as the high level design, and the detailed design is also known as the low level design. In the high level design, we firstly decompose our system or software into the different modules or functions. Then we represent the innovation relationship between these modules. We specify after the decomposing of the system into the modules, we will specify the relationship among the different modules. That is also known as there are two different methods for specifying the relationship between the different modules. This is known as the cohesion and coupling. Cohesion is known as the relationship between the two different functions regarding the functional strength and interrelationship between the two different modules. In the detailed design, the different modules design in greater detail. The data structure algorithm for each module is also required to be specified in the detailed design. The second one approach of the design phase is the object oriented design. As you remember, regarding in the design phase, we are saying that two different approaches. First one is the function oriented approach and second one is the object oriented approach. After the completion of the function oriented approach, now we are starting about the object oriented design. Object oriented approach. In the object oriented approach, we are first identifying the various objects occurring within the problem. Objects are basically real world entities like that have some particular kind of properties. Object is the real world entities that is defined by its properties, like when we are if we see in our room about the different objects, we will see we have table, that is the object, we have chair, that is the object, we have computer system, that is the object, we have a printer, that is the object, we have a AC, that is the object, because all these are the real world entities that have some properties and some different kind of functions to be applied on those particular objects. After identification of the different objects occurring in the problem, we have to find out the relationship among those objects. For example, now if we are considering about the payroll software, we have to design a payroll software of the particular organization. In that particular organization, the different objects will be the employees working in the organization, the managers working in the organization, the payroll registers, the different departments. In this way, we have to find out the different objects in the particular software. For each software, we have to separately identify the different objects available, and after identifying the different objects available in the system, we have to define the relationship between those particular objects. Object structure further refined to obtain the detailed design. In the object oriented design has several advantages over the the previous one approach, that is the functional oriented approach, these advantages are likely the object oriented design approach require lower development effort, lower development time and better maintainability as compared to the traditional or functional oriented approach. For that reason, in the today environment, the criteria followed of the for the design phase of the software development life cycle is the object oriented design. In the object oriented design, as in the structure in the functional oriented approach, for representation of the functional oriented design, we are using the data flow diagrams. In the same way, in the for specifying the object oriented design, we are using the UML diagram, that is unified modeling language. UML means unified modeling language. In the object oriented design phase, we are specifying the object oriented design to the user by means of designing the different UML diagrams. There are different kind of UML diagrams accordingly, the use case diagram, the activity diagram, the sequence diagram, and a number of diagrams are available for showing the relationship among the different classes and objects available in the system. That objects are specified by means of object diagram in the system. The next one phase of the software development life cycle phase is the implementation phase after the design phase. The purpose of implementation phase is to the coding, the convert the requirement, the convert the design phase into the particular programming language. In the software development life cycle phase, requirement analysis phase, we are specifying what is the problem. In the design phase, we are specifying how the problem is to solve, and the implementation phase, we are converting the problem design into the particular programming language followed by the specific organization. The implementation phase is the basically collection of two different phases, that is the coding and unit testing phase. In the implementation phase, we translate the software design specified in the previous phase of the SDLC into the source code, into the coding in the particular programming language used by the organization. During the implementation phase, each module of the design is separately coded by specific program by the particular programming language for the software development. Each module is after the design of the separate module, each module is required to be unit tested individually. We are saying in the previous phase, we have to firstly identify the different modules available in the system, and then we are coding the different modules of function in the system, and these modules are required to be independently tested. Stand alone, these modules are required to be tested again and again for finding out any problem in the any kind of error or warning in that particular module. That a module is unit tested by means of designing the different stub modules. Each module is required to be documented after the coding and unit testing. The purpose of unit testing is to test if individual modules is working correctly. The end product of the implementation phase is a set of program modules that have been tested individually. These all modules are not tested collectively, but in the implementation phase of the system, we are writing down the code for the individual module, and we are testing the each module individually, not collectively. The next one phase is the integration and system testing. That phase is the in this one phase, we are testing the different modules collectively. Now here in this one phase, that is the collection of two different phases, likely the first one is the integration testing and second one is the system testing. Sorry. In the integration testing, we are checking when the different modules are collected together, when the different modules are integrated in the planned manner.